Hi, my name is Javier Rodriguez. Today I'm going to talk about OPP in Python. I'm a student in computer science. I'm doing my OPP in Python class, and I'm going to explain some topics of it, really important topics. Most of them are going to be classes, encapsulation, inheritance, objects. So let's start. Hopefully, these don't take too long. So, to begin with, objects. Objects represent entities with characteristics, properties, state, and actions methods. In essence, objects encapsulate both states and behaviors. Each object is an instance of a class, and classes are defined as blueprints of creating objects. Well, what are objects? Whatever you name it. You can take a card, like in the example here. I'm gonna use my laser here. Like, objects can be this car, right? Can be your phone. Can be a cup, whatever you want, glasses, a shirt, it can be whatever you want. And in this case, we have a car. State basically is what is it, right? What's the name of it? The color, made, model, submodel. Um, yeah, that's basically it. As for behavior is basically aspects of the car. More important information or more specific to be more clear, right? Like HP, horsepower, tire pressures, speed, fuel efficiency, well, top speed, fuel efficiency, um, and all kind of that information, right? So a class can be defined as a blueprint that describes behaviors and states. Like previously mentioned, objects in OPP have a state and behavior. Again, how to do classes? You just write class and then the name of the class. In this case, we have pass because we're still not going to use it, but it's already set there. Property and attributes of object. Instance attributes are specific to each individual objects, where an object is also known as an instance. An example can be the use of car as an object. Of course, you can use whatever you want. You can talk about animals. You can do bank account, whatever you want. It's basically up to you. Each have its own characteristics like brand, model, year, and etc. Right. Modifying these attributes in one object does not impact in the attributes of any other car objects. So adding or modifying should not change any car objects already done before that, right? So what is an instance attribute? It's also known as init. It's Spanish, so I don't know how to pronounce it all, but I know it's written like this, right? And this is also known as initializer. I would like to call it initializer. So for the next part of the video, I'm gonna say initializer. It automatically invokes when a class is initiated. Its role is to ensure that the class has all the necessary attributes and is often employed to verify that object is a valid state upon installation. So it confirms that the information is correct, basically. In the case of a year, if you put a negative number, then it's gonna not let you to put in, right? Because it's wrong. It should be positive numbers when we talked about years. If you're in case of numbers, right? Names also can be it's more specific on that. So yeah. Oh, to follow up with how to do a class, you do again class, name of the class, and your definition or function. It's more called like function. You have your initializer here, 2 underscores, then init, and then 2 underscores, then parentheses. You do self, important, do always self for it to work. Then use brand, model, year. If you come from C++, most of the time at the beginning you're gonna forget to do this. You're gonna forget about this, but it's really important, so we have to do it. Brand, model, year, and again to make it a variable itself, you have to do self.brand equal to brand. You can do equal to b equal to m here equal to y. I think it's gonna work. I've seen people doing it. I prefer to do it this way because it's more specific to do it like that. I prefer it more good to that muy easier, vaya. Entonces, yeah. Let's go. Accessing instance. After creating an object and its instance attribute, you can access the attribute using that operator. This image came really bad, so I'm gonna go to the next slide. But basically, it's the same thing as you can see here. Basically, you do your class. You can have here your variable. Again, you can do this with the initializer and all that, so it basically almost the same. You have here brand. In this case, it's Volkswagen. I know this should be in space here, but I put and you can do whatever layer you want. You can use C because car. If you do E, it's gonna work fine. Important thing here is you have to say a variable. You make the variable that is your class, and then you do print, and then you do your seed that, and you put brand, model, whatever you want, being whatever you want to know or to print here in the console, it's gonna do it. But you gotta put this here. Very important. And see that? Very important, very important. So let's go. Define a method in a class. Okay. So there are two ways, or more like three. The last one doesn't go so far from this. And either way you can use it. It depends on you. Whatever you feel is more easier to write or faster, or whatever you feel more comfortable with. But in this case, you do the class again, you do your initialization, and then you do your function. And this is the important part. So you can do display brand, and you do here self. Why you do self here? Because you want to call upon this here, and this. Basically, you call more upon this. So you do print, you do self that brand. Same thing we do for print that you use see that. It's the same thing. You just use yourself, right? So in this case, you could put self that brand, and then you have here your C equal to your class. Again, your class here, you have in this order. You have brand here, you have model, you have year here. So you do C display brand, call upon your function, and it should display here Volkswagen or my VW, right? Whatever you have, you can display here. You can do the same thing if you do display model, print self that model, and you should call upon model when you do the display model. See that display model? That's a way to do it. You can do it like that. Another way to do this, again, you do your class, you do your initialization, you go to your function to get model, then self, then you do return self the model. Whenever you do get, it's really important to use return. You can use print because you're gonna use the print from outside. So you see here your C right is equal to car. Again, same base as here, and then you do print difference from here to here, right? So basically it's the same thing. You just call here your function has already print here, but then here you have a get model function. So you do return, you do print, parentheses, see that get model, and your parentheses, and you should call upon this, send it to here, and print it, which is your Go of GTI, you're calling here for model in this case, right? You can do the same for year, or whatever you have here. You can have more bin, whatever you have there is gonna work like that. Sorry. Inheritance. Inheritance is a concept where we extend the functionality of a class to create new classes. There are benefits of doing this. The reusability of code from an existing class that has a generic code that can be reused. This class is called parent, base, or superclass. Child classes that will receive the definition from the parent class. So whatever you have a class, like in this case is core, you see how you have like bean, brand, model. You can create child classes. In this case, I did car because I like cars. So I took this image is just to follow up, right? But you have this information here. So whenever I use these functions, like here, like truck, SUV, sedan, sports, basically you are putting truck and then truck class, right? Well, in this case will be more like class truck, then parentheses car, and it's gonna call upon this here. So you don't have to write each time. You can do it. It's possible if you want to do it. Go ahead. But that's why you use like super and all that. So yeah, like we're gonna see about it about now. So parent and child classes. Parent for me is like the main class. Child, I use it like subclasses because I think that was called in C++. That's how I learned it. But it basically is child. You're even gonna see it in algorithms when you see trees and all that, because trees are from the roots of the tree. Of the trees, you can call these leaves or childs. But that's off topic, right? It's a little bit of me to you. So yeah, you have here your class again. You do your subclass. You see how it's out of this class. Make sure you do the indentation here because it's really important. If you keep it like next to it, it's not gonna work. So yeah, because the class is supposed to be a class itself, a class by itself, right? So you see how you have class here, and then sports car. In this case, I put sports car. You can put drug, whatever you want, and you do car here, which you're gonna upon this, upon everything here. So you're gonna use here on pass, right? You can call M1, M2, whatever you want, the sport car, and you put the model, the brand, model, year. Make sure to follow this order. And even then, if you don't follow this order, whenever you call brand, it's gonna call Golf GTI instead of Volkswagen because you put this here instead of here. So just to have that in mind too. How you print it? You do print M1 dot model. Again, same concept as the dot process, right? Or dot function. Sorry. So yeah, here we call upon model. We have Golf GTI there. So, yeah. Override. Inheritance methods can be defined in a child class. So this is the first step for it, actually. But yeah, again, you do your class here. Here is where again, sometimes you don't have to use this. You can use super, and super is gonna call upon this here. Different thing here. You don't have to put everything like this here. So yeah. Definition or function, you do this again, brand. So for example, you have this here, right? This is gonna be the class main parent, so this is never gonna change. But in every single one, in case of you do truck, in case you do car, you can, in case you truck sports, you can put different things. Actually, submodel could be here, but in case of sports car, you can say like, oh, horsepower, and you put it here, right? And you put horsepower equal to horsepower. Well, set that horsepower equals horsepower, and then you can call upon it, and it's gonna be like, okay, it's gonna give you like that specific information. In this case, for a sports car, so basically you have the same base, but each time you can put like something special to it, like in case of forecourt, horsepower. In case of trucks, how big are of how big are the seats or suspension, each time, right? Really specific things. Again, you call the same way like we did before. So let's keep going. Inheritance methods can be redefined in child classes. If you want to reuse parents, you can put it under override method. Again, override method is same way here. You can put car. We're about to get there for super, but this is a way to do it too. Again, you put here your submodel, then you call it upon again. So that submodel, you define it, and you call against to it. Again, you can put M1 put submodel, and it's gonna give you information about it. And this point, so yeah. If you want to reuse the parent method too, you can put it under override method instead of the parents class. You can use super function. So super function, if you pay attention to the last one, here we had car, which is calling it this, but instead of that, you just put super. It's gonna do everything for you again. Kind of the same thing though, but it's more specific to use super. I think it's way better to use this. It's the same thing basically. But yeah, you can use it. I think it's whatever you prefer. Most of the time, in exams and all that, we're gonna ask for this. So, yeah. So we start with this topic, polymorphism. What is it? It's a fundamental concept of object orientation programming, of OPP, that allows object to make multiple forms. To take multiple forms. Enables one interface to be used for a general class of actions. The specific action is determined by the exact nature of the situation. One interface, multiple implementations. So you have this this interface. then you have your child classes. Like again, you can put whatever you want. I took it from internet, but the race cars, SUV, compact, sports car, and all that. And car objects can be like the mates, models, and all that. So yeah. So why it matters? How it works? Why it's so helpful? Because of code reusability. You don't have to, again, write something new every time. You can use the same piece of code to interact with these objects, even from different classes, and in a really unified manner. So yeah. Again, this means you can write more generic and reusable code, more simple and straightforward, to be honest. So yeah, flexibility make it easier to introduce new classes and objects that work seamlessly with existing code. As a result, your software can grow and evolve with minimal changes to existing functionality. So that's those are some reasons of it. There's a method here, method overloading. Method overloading allows multiple methods in a class to have the same name but different parameters. It's common in many programming languages for implementing polymorphism at compile time. Makes faster the response from your code, basically. Some effects of this is the effects of this can be default parameter values. Python methods can have default values for parameters. This feature can mimic methods overloading by allowing the method to be called by different numbers of arguments. So again, here, how you do it, you do your function, you do your name, age, your variables here, and you do an if else statement, which is really helpful though. You do age, print name is equal to, and age, else print name. Okay, so you see how you use this 2 times, right? So in case this is none, whenever you ask the the user, it's gonna only print name. For example, display John, and or you can you put this here? Okay, yeah, John, and it's gonna ask you like, or the age, none, and then it's gonna be like, oh, only John, and if you want display an age, it's gonna be like this. It's just in case you put these two, you put this just the name, it's gonna be the name. That's it. So variable length arguments. Non-key arguments allow methods to take an arbitrary number of arguments without defining them all. Asterisk args. Here how you do it: definition add, and then you do your asterisk numbers, random sum of numbers, print add, and then you do this combination of numbers. This should be add into the console and displayed. I didn't get the display because yeah, I forgot about it, sorry. But yeah, two asterisk keywords, keyword arguments, again, as keyword arguments, but I like to say it like that. Sounds funny. Enables passing a variable number of keyword argument to a method. So basically, you do here properties, your name, pet name. You do for key value in properties that items, and it should go to here. And you do key, you put the name Kato or Gato, then you put the age, tree, color, black. This is just in case you do not do this like species, but if you want to be more specific, then you do this, and it should go here, and should print it, right? With basic key is supposed to be just these things, but if you add something else, it should add this, right? Yeah. Oh, actually, I say wrong. Key should be this, and value should be all this. All this. Yeah. Operator overloading. This allows operator to have different meaning depending on their operands. In Python, this is achieved by defining special methods in classes, often refers to as magic methods. Flexibility and intuitiveness enables custom behaviors for arithmetic, comparison, and other operations on objects of user-defined classes. No, it also has readaptability, allows more natural and expressive or simple code that aligns with the operator being performed. For me, it's more like it's more easier to understand. It lets you play more with it, and it enhances a lot the understanding of it. You can get it more um, with this uh, with the operator. Yeah. Python implements operator overloading. These are called magic methods. This can begin and end with the double score underscore. These are used for any operations like add, sub, multiplication equations, even for equality, sorry, even for sub division and all that. So these are basically some of the functions you can use to make your life easier with these kind of operations. An example of this is vectorial addition, an scenario defined vector class where vectors can be added using the plus operator, which is the sum. You have your initialization, you do your variables, you do your function here, underscore add, underscore self, other. This is just to make it really ambiguous. You can put whatever you want here. I mean, here on the screen. Yeah. You do return vector, you do self.x, x plus other x, then self.y plus other y, and you can put here like v1 vector is 1 minus 2, then vector 2 is 3 and 4, right? So in this case you can have here two operations at the same time. Sometimes you can put a multiplication here and a division. You can put like plus and plus, and it's gonna add up these numbers. And yeah, of course, this is just to put a value to them, and then the v3, which is the important part, is gonna add them. You see how I have v1 and v2? Well, then you print v3.x and v3.y. So it's gonna take the x's from here and the y's from here. That's why it's important to do this also. And it's gonna do this operation. That's why you have it here: y and y, x and x. That's a way to simplify addition. You can do the same thing with multiplication. Yeah. Benefits of operator overloading: intuitive operations like before, like the one I showed you. And I think custom behaviors. It supports defining how user-defined objects should interact through familiar operator, enhancing the expressiveness of the language. I know this is not that part of OPP, but it's important to say because most of the time you're gonna use operators to do that, so it's really important to see. Yeah. So let's keep on. Now another topic is encapsulation. Encapsulation is a fundamental principle in object-oriented programming. It involves bundling the data, attributes, and methods functions that operate on the data into a single unit or class. And restricting access to some of these objects components is really important. The purpose of encapsulation is data hiding and simplifying interface. This is basically your private and public information in C++ classes. It's basically the same. It also access modifiers. Again, public, protected, and private. To implement encapsulation with more lenient approach compared to other languages, public members, protected members, private members. Even you can use private functions, private methods. It's kind of the same, but basically this make it accessible for anyone. Um, protect information here, and okay, yeah, accessing restricted to within the class only. This one I forgot. Sorry. Private member. How you do a private member? Well, this is an a way to do it, right? Here. Okay, there you go. You have here your private variable again. You have two underscores speed. This is not gonna be accessible by the user. And each time you see one of these here, it's not accessible for you, for the user. Only the person that is coding is gonna be accessible to it. This is made for it to not be changed by the user, because sometimes you don't want your information to be changed. It's a private method. This is some example, right? This method you cannot, you cannot access it. You can have whatever you want here. And that's it for this one. So let's go. You have your class vehicle here. Your protected attribute. Again, you also can protect your variables or attributes here, so they're not changed. Your protected method here. Again, you have your public attribute here. Whenever you have it like this, it's gonna be accessible. Again, this can be changed. Here in this case, this can be changed, but brand and model cannot. Just the year can be changed or add upon. This is how to access the protected method from the parent class. Here, you do this self. In this case, we had my car, Volkswagen GTI 2015. This is a form to do it, but it's not recommended. It is possible to access it from outside, any attributes or methods that are protected, but it's not too recommended. It's gonna take a little more time, and sometimes in your console it's gonna be repeated information. That's why. And using this method is how you can actually code them. So yeah. Abstraction is hiring unnecessary implementation details and exposition only the required interface or functionality. An abstract class can contain concrete implemented methods, but must include at least one abstraction method. A method with no implementation cannot be initialized directly. Interface in Python typically simulated via abstract classes. Specific methods or properties, a class must be implemented. In the case of menus and all that, but yeah. Basically, abstract is kind of necessary information. Most of the time, you're gonna have a lot of unnecessary information, though it's really necessary for when you're using it, right? For the person doing the code, but for the person that is using the console or the code, in the case of adding cars and all that, you don't have to know everything. So it's just like, oh, just add this, and it's gonna be going around right around the memory. So yeah. Relationship with OPP principles. Again, this is what we saw. Before encapsulation, inheritance, and polymorphism. This go all together basically, and I would say the more importance, or everything is important, right? But even more important, I think, is encapsulation that protects the data. How you can pass this protected data to another ones. How polymorphism lets you move around with the same interface you used before. As for the classes, I mean, yeah, I think that's it. An example of abstract method can be this. You use this typo, then you define a function, and you do this. In this case, gonna print ng to start, basically, like it's here, right? So yeah, this is a example of how to do it. And that will be it. Thank you for your time. It took me 3 minutes. I kind of rushed a little bit at the end. But yeah, sorry. Yeah, I think that'll be it. In my opinion, OPP is a really, really good class. I think it's really important to know. You see some of it on C++, but I think it's way better here. You have a lot of parts of it that at the beginning may be difficult to understand, but at the end everything is connected to one thing, and I think it explains classes itself and how it works. Even in the using security, it's really important, and I can see why, right? The the ability to enclose information, to hide it, to make it so the user cannot change it, because it's really important. Even when you're doing like the database in Python, you have information about a car, you don't want people messing with it. If you can let them just see it, or you can let them just add to it, but not the information you did itself. In case more you had to add more information, in example, add another car, information about another car, get information from that car. Of course, there is information that you're not gonna be seeing, right? You can make it so that you don't have to see like the number of the car, the VIN title, or something like that, right? It depends on your classes, on your subclasses. So yeah, I think that'll be it. Thank you for your time. I hope I help you to learn a little bit more. I'm still looking around for it too. This helped me to see again the topic. I'm still gonna keep, you know, learning about it. So yeah, hopefully you have a great day. Thank you.